energy changes associated with the reactions. See, in a chemical reaction, there are many, there is a very big hint, there is a very big aspect, that goes on in any chemical reaction. That is nothing but energy changes. Whether the energy is absorbing or whether the energy is releasing, okay, that will give a very big information about what is going on in a reaction. So, we are going to come about, okay, energy changes associated with the reactions. So sometimes in a reaction, energy will be absorbing, in some cases energy will be releasing. So the energy changes you can say in a broad manner, okay, so energy changes, okay, so this could be, if it is a releasing energy, so this could be exothermic. If a thermodynamic system, if it is absorbing energy, this is going to be endothermic. Okay, it can be exothermic also, it can be endothermic also. So in exothermic reactions, the energy will be releasing out. In endothermic reactions, the energy will be absorbing inside the system. Let's see how this is happening. We will see some of the common examples. See, for example, let it be on reaction. Okay, so let this be a beaker that containing some amount of calcium oxide. Calcium oxide. So you will pour water. Okay, so you will pour water, and when calcium oxide you are putting into water, so you can say this is going to be, okay, calcium hydroxide. Okay, so calcium hydroxide will form. Actually this reaction, it is a energy releasing reaction. So if you touch into the side of this beaker, okay, then you will feel that it is very hot. The hotness you can feel. So this reaction is releasing energy. So this is going to be exothermic. Okay, so and here again, if you want me to say one more example, let it be a test tube. Okay, example. Okay, so this is let it be iron granules, and you are adding sulfur. So this sulfur, when it is burning with the iron. Okay, so this is going to be FES. Actually, for this reaction to happen, initially you should supply some amount, a small amount of heat. So it will become very reddish hot, and it gives some more amount of energy. Actually, lot of amount of energy it will release out. So this surface, this test tube surface, this is going to be a reddish color. So what should happen is, this reaction is also giving lot of amount of energy. It's, if you touch it, if you touch on the surface of test tube, it will become very red hot. It will become very reddish color in nature. Okay, so it will be hotter in nature. So this is also an example of exothermic reaction where the energy is releasing out. Okay, and if you ask me another reaction, okay, you can consider a test tube. So this is going to be silver nitrate, AgNO3, and AgNO3 solution. Okay, AgNO3 solution. You are adding sodium chloride. So do you know what will happen when these reactions are happening? We will write the reaction NaCl plus AgNO3. This gives silver chloride. Just some double decomposition reaction will happen. Of course, these reactions are not important here. Still, just for some better understanding, I am writing. Okay, AgCl plus NaNO3 will form. Okay, so this will release us again. This reaction also it releases some amount of heat, not that much, but you can feel the hotness on the surface of test tube. So these reactions are in fact exothermic reactions. Let us look a little more closely what is happening here. Energy changes. Let it be exothermic or endothermic. Okay. See what is happening actually. The reactants, whatever the reactants it may be. Reactants, it gives products plus energy. Okay, so it is giving products and energy. So when the reactants are converting, it also gives the products, and like it releases some amount of energy. Obviously, when we are drawing a energy level diagram, suppose you can see we are drawing an energy level diagram like this. Okay, so what will happen is actually here the energy. Okay, here actually the let it be the products. So suppose this is the reactant. So this is the reactants. When it is converting into products, okay, products here. So some amount of energy might be releasing. So actually this difference, this difference is going to be the energy, total energy within the internal energy within the reactants, and within the products is the there will be some difference, right? So that difference is the energy. For different reactions, different amount of energy will be releasing. For example, you have seen the reaction, Fe plus sulfur. So this gives FeS. So when this reaction is happening, for example, 56 gram of, and you will come to know later, this is nothing but a 1 mole. 56 gram of iron, when it is reacting with the 32 gram of sulfur, so this is going to release almost 100 kilojoule of energy. So this much of amount of energy is going to get released when this reaction is happening. Okay, so the endothermic, exothermic reaction, whenever that reaction is happening, it is going to release some amount of energy, right? So there are many exothermic reactions. Very fundamental and common one we are every day we are witnessing is a fuel. Okay, many fuels are there. Yeah, normally petrol, diesel, kerosene, and lot of fuels are there. Fuels, when it is burning, actually it must releases energy, and quality of a fuel. See, quality of a fuel, that depends how much amount of energy it is releasing. For example, fuel 1. Okay, so this is releasing 200 kilojoule, okay, and fuel 2, so this is releasing 300 kilojoule of energy. Definitely we have to take this 300 kilojoule of energy as the best fuel, okay. So this is the fuel that is going to release more amount of energy, am I right? So here again we need to know another thing, that is there are many other reactions apart from this fuel. You can also say calcium oxide, neutralization reactions, all the neutralization reaction. For example, you can consider HCl, okay, and you are adding sodium hydroxide, okay. So this reaction will releases NaCl plus H2O plus heat. For any reaction, any neutralization reaction, okay, any neutralization reaction, if you are touching on the surface of this beaker, that is going to be very warm, okay. Any neutralization reactions, let it be between HCl and NaOH, or like HCl and potassium hydroxide, any neutralization reaction, that is also going to be exothermic reactions in nature, right? Okay. So we have to talk about endothermic reactions. See, exothermic reactions we have already talked about. Exothermic reaction that releases heat towards the outside. Endothermic reactions, it absorbs the heat when any reaction is happening. So there are many examples. Of course, some reactions probably you can check in your home itself. We all know glucose. Whenever we are falling sick, or maybe when athletes, we are running for some athletic competition, what we do is, as an instant source of energy, we drink a glucose, right? So, have you ever observed one thing? If you now, at least now you can observe. So, when you are putting glucose, okay, so when you are putting, take some amount of water. So you put a glucose. So what will happen now? After some time, you hold the surface of this, this tumbler, or your tumbler. So you will find that the surface of this beaker, it is getting cold. So actually this is due to endothermic reaction, because this dissolution of glucose. What will happen is, for that it will require energy. So it shall absorb energy from outside. So the energy is even from the surface of this test tube also it goes inside. Okay, so this is what it is happening in the case of glucose, and it's how it is absorbing, and yeah, for this dissolution it is nothing but an endothermic reaction. Now, endothermic reactions, there are many endothermic reactions in the laboratory. If you are going to see, you can check on them. Okay, so the reaction, say like barium hydroxide. Okay, the reaction between barium hydroxide and ammonium chloride. Okay, do you know what will happen? Barium chloride and barium hydroxide and ammonium chloride, if you are mixing, the same phenomena can happen. The surface of this beaker, this is going to be cold in nature. This will get cold. The surface will remain cold. Okay, so this is again nothing but endothermic reaction. There are one more example if I tell you, that is this calcium carbonate. Okay, so let it be leave a beaker and we will consider a crucible. Okay, so you are heating the crucible containing calcium carbonate. So this is nothing but calcium carbonate. Okay, so calcium carbonate. So when you are heating, do you know what will happen? This calcium carbonate, it will decomposes into carbon dioxide, and what will remain here is, okay, after some time in the crucible, what will remain here is calcium oxide. Okay, calcium oxide will remain. So carbon dioxide and all it evaporates away, calcium oxide will remain in the crucible. So even this reaction is an endothermic reaction, because only when you are heating, this reaction will happen, because you need to supply the heat. Internally. So this, in order for this reaction to happen, 178 kilojoule per mole. For 1 mole of calcium carbonate to decompose, you need to supply 178 kilojoule of mole energy in order for the decomposition. So that is what this reaction is. This reaction is nothing but an endothermic reaction. You need to supply as much heat as 178 kilojoule of mole. Okay. So these reactions are called endothermic reactions. Now, so here we need to know one particular concept, that is called spontaneous reactions. Okay. See, spontaneous reactions are, you have to know, see, if some reactions are happening itself without heating, without stirring, without doing anything, such reactions, without the aid of anything, that happen by itself, that is called spontaneous reactions. For example, here you have seen a reaction, that is, okay, see here what you have seen, this is actually ammonium chloride. So, ammonium chloride, I am sorry. Okay. Ammonium chloride, okay. And when you are actually dissolving barium hydroxide, suddenly this surface is getting cold, suddenly, okay. So this is an example of endothermic reaction, because that cools itself, you are not doing anything, okay. The reaction is happening itself. On the other hand, you can consider another reaction here, okay. So this is actually, okay, so this is actually calcium carbonate. So when you are heating, okay, you have to heat, you have to supply heat, then only this is releasing carbon dioxide and decomposition of calcium carbonate is happening, so that this is forming calcium oxide. Okay, so this is forming calcium oxide. So what is the thing here? You are supplying heat. This is not a spontaneous reaction. This is a non-spontaneous reaction. That because it requires additional source of energy. Okay, you can't run this reaction without the help of external energy. Now, there is a similar way the energy level diagram, if you are drawing here, okay, so this is actually the energy, here, this is actually the reactance. Reactance will be in the lower end of the energy. It acquires energy and it goes to the high level. Okay, it goes here, and this is actually the products. Okay, so this is actually the products. So the products will be having more energy than the reactants. So maybe like 100 kilojoule. For example, this for this particular reaction, see, calcium oxide is the product, calcium carbonate is the reactant, right? Okay, calcium carbonate is the reactant. So what shall happen is, this reactant, that means calcium carbonate, it acquires more energy. So for one mole, it has to occur 178 kilojoule of energy, and it goes to the products. So the product is having, compared with the calcium carbonate, calcium oxide, this is going to have 178 kilojoule of energy excess. Means, like it has to absorb this much amount of energy and it goes to this level, so that the products are having more energy than the reactants. So there are many endothermic reactions which you will see familiar in the laboratory and done. Okay, so that is it about exothermic and endothermic reactions. Okay, good day.